Hi, everybody. Today we're going to talk about periodic functions. We will graph sine and cosine functions in particular, identifying period, amplitude, and horizontal shifts. But first, we do need to talk about a definition for a periodic function. A periodic function is some function such that f of the quantity t plus p is equal to f of t for some value of p. So a horizontal shift of p units is going to mean that this function has the same look as if it was just f of t, right? That it does not change the graph, the look of the graph. So for example, a periodic function that we should be pretty familiar with is y equals the sine of x, or it's a sine of theta, I guess we're using this time. And there's a picture of a couple of cycles of y equals the sine of theta. Its domain is all real numbers. You can take the sine of any real number you want to. The range of the sine function, it has a minimum value of -1 and a maximum value of +1. So that gives us the range. What is the period? What do we even mean by the period? The period is the amount of horizontal, the length of the interval over which these cycles repeat themselves. So I'm going to highlight one period of this graph, and you can see that that interval is 2 pi in length, so that 2 pi is the period. If I highlighted this one over here, that's also a length of 2 pi. Or I could measure it from low point to low point, from -pi to positive pi. Well, that'd be middle point to middle point. Low point to low point would be -pi/2 to 3 pi/2, right? I could think about it that way, from -pi/2 to +3 pi/2. That's also a distance of 2 pi. Or if we went from, like I say, from -pi to pi, that's a distance of 2 pi, right? So the period of this function is 2 pi. What do we mean by the amplitude? That's not max minus min. It's how far do we stray from our kind of central axis here. So there's an amplitude, and the amplitude here is 1. So from the x-axis going up, or the theta axis, I guess, or you could measure it going down as well. But it's how far are its extreme values from the center, as another way to think about amplitude. Okay. And here's y equals the cosine of theta, very similar periodic function. It still has the same domain as the sine function, namely from -infinity to infinity. It has the same range. It has the same period. It looks like as if you took the sine function and moved it maybe pi/2 to the left, or possibly 3 pi/2 to the right. But in any case, it has the exact same shape. It's just been slid horizontally a bit, and it has the same amplitude, namely 1. Okay, if you graph on your calculator y equals the sine of 2x, and you do it on the interval from 0 to 2 pi, meaning 0 is your x min on your calculator, and 2 pi, or Desmos, and this would be your x max. And of course, you want to be graphing these in radians. We will be pretty much graphing in radians in this class. How many cycles do you see? And you might want to pause the video for a minute and take a look for yourself. Okay, if it's y equals the sine of 2x, you should see 2 cycles. And if there are 2 cycles over a period, over a span of 2 pi, an interval width of 2 pi, and you see 2 full cycles, then the period has to be pi for each of those cycles, right? So when we replaced x by 2x, that is a horizontal compression by a factor of 1/2. So what it does is it compresses the period from 2 pi to pi. We can do something like that with y equals cosine of 3x. Again, on that same interval, you don't have to change your viewing window, just change your equation. And if you take a look, you will see that there are 3 cycles over an interval of 2 pi, right, of width 2 pi. So if it repeats 3 times over that interval, then the period for each cycle should be 2 pi over 3. Just divide that 2 pi into 3 equal pieces. So in summary, if y equals sine of kx or y equals cosine of kx, then the period for each of those is going to be 2 pi over the absolute value of k. Why do we need absolute value of k? Because we don't talk about a period of a function as a negative number. Okay? It's always a non-negative type of measure. So we need that absolute value in there in order to have the correct period. If y equals 3 sine of x, that means that we have a vertical stretch by a factor of 3, so that gives us an amplitude of 3. If we look at y equals negative 2 times the cosine of x, that's a vertical stretch by a factor of 2. We also have a reflection across the x-axis, but in either case, the amplitude becomes 2 because of the vertical stretch. And so, in summary, when we have y equals a sine of x or y equals a cosine of x, the amplitude is the absolute value of a. And again, we don't talk about amplitudes ever as negative numbers. All right, so if we have y equals a sine of the quantity k times the quantity x minus b, or y equals a times the cosine of the quantity k times the quantity x minus b, the amplitude is the absolute value of a. The period is going to be 2 pi over the absolute value of k. And the horizontal shift is b, and it's b to the right if b is greater than 0, and it's b to the left if b is less than 0. For example, if we have y equals 7 times the sine of 3 times x minus pi over 6, this one would have amplitude 7. We would have period 2 pi over 3, and it would be pi over 6 to the right. Okay, we replaced x by x minus pi over 6. So again, that's an example where the b is greater than 0, because remember, it's x minus b. It's x minus positive b, right? If I had y equals 3 cosine of the quantity 2 times the quantity x plus pi over 3, this one has amplitude 3. It has period 2 pi over 2, which is just pi, and it's pi over 3 to the left, because that's like x minus negative pi over 3. So again, that's a shift of pi over 3 to the left. All right, here's an interesting one that it wants us to graph. Y equals negative 3 times the sine of the quantity 2 times the quantity x minus pi over 2. The period is 2 pi over the coefficient of x, so that's going to be pi. The amplitude is 3, and the horizontal shift is pi over 2, and that's going to be to the right. We don't, fortunately, have any vertical shifts. The amplitude is 3, and unfortunately, I didn't do a very good job of giving myself room to do a horizontal, or I mean an amplitude of 3, so I'm going to have to come down here a little bit farther and go a little bit farther up to put a positive 3 up here. So that's one thing I want to do. So I've accounted for my amplitude. The period is pi, but I have a horizontal shift of pi over 2 to the right. So the regular sine graph goes right through the origin. So if I'm going pi over 2 to the right, I'm going to have to shift that point by pi over 2 to the right. Remember that the original sine graph goes up before it goes down. Because we have a reflection there, that negative in front of the 3 gives us a reflection. That means this one's going to go down before it goes up. I'm going to draw one cycle, but I need the other end of it. If the period is pi, the other end of my first cycle is 3 pi over 2. And halfway in between there is pi. So I've identified my intercepts. Let me see if I can get this drawn reasonably well. And I wrote right where I need to be. So something like that. Okay, halfway between pi over 2 and pi is 3 pi over 4, and the y-coordinate there is -3. And this point up here is, its x-coordinate is between pi and 3 pi over 2. Okay, so how do we find that? Well, that's going to be what? 5 pi over 4, because it's pi over 4 past pi. So 5 pi over 4 and +3. Okay, so we've got one cycle. Now there's a number of ways that you could check this. You could take your graphing calculator or Desmos and graph it, and I'm gonna impose, I don't know how well you can see this, a viewing rectangle. So I'm gonna do it just like this. And so on Desmos, I'm gonna use X-min or any graphing calculator as pi over 2, and X max as 3 pi over 2. And I'm going to use Y min as -3 and Y max as +3. And if I've done everything correctly, then this should be exactly what I see when I use my graphing calculator. Okay, that's a way to check that you have the correct graph. There are some other things that you can do as well. For example, if you want to check the point 3 pi over 4 comma -3, that might be something kind of fun to do. So I know I'm supposed to have y equals -3 times the sine of 2 times the quantity x minus pi over 2. And so if x equals 3 pi over 4, then let's see what y equals. -3 times the sine of 2 times the quantity 3 pi over 4 minus pi over 2. That's -3 times the sine of 2. 3 pi over 4 minus pi over 2 is pi over 4. That's -3 times the sine of pi over 2, because 2 times pi over 4 is pi over 2, -3 times 1, or -3. And that is exactly what we have there. So that's kind of a way to double check if you're not sure whether your points are good. So there are a number of ways to check your graphs. Okay, this is the last one. And hopefully, I think I gave myself enough space here to do this one. Y equals 2 plus 3 times the cosine of the quantity 3 times the quantity x plus pi over 6. So we have all sorts of things going on. We have a vertical shift. We're going up 2. We have vertical stretch by a factor of 3. We have a period of 2 pi over 3. And we have a horizontal shift of pi over 6 to the left. Okay, we have a lot of things to consider. Let's think about that amplitude. Oh, I didn't address that either. The amplitude is 3. Without the vertical shift, the maximum value would be 3 and the minimum value would be -3. But if I shift it up 2, my maximum value now is at 5, and I'm going to draw this not as an asymptote, but as a drawing guide, because it's a lot to remember. My minimum value would be -3 plus 2, or -1. So there's where the minimum points go. Okay, so what's halfway in between there? Well, the y equals 2. That's the center of the oscillation back and forth, or up and down, however you want to call it. So those are drawing guides. So this is going to go up so much from y equals 2 and down so much. So I, at least when I start to draw, I don't have to remember quite so many things. So I've kind of given myself a framework. Now the things that I have to worry about are going to be the period and the fact that we have to do pi over 2 to the left, or pi over 6 to the left. because I know that 2 pi over 3 is a 4 pi over 6, my thought process was to use tick marks every pi over 6. So half of pi, that's pi over 2, which is equal to 3 pi over 6. So 1, 2, 1, 2. There's negative pi over 2. So each of these little tick marks represents pi over 6. So that's going to help me a little bit with my sketch. Okay. This is a cosine graph. Normal cosine graph starts on a high point. So we haven't done any reflecting here, but we do need to go pi over 6 to the left. So I need to put a point right there, and that's going to be at negative pi over 6, comma, 5. Okay. The other end of this cycle is 2 pi over 3 going to the right. That's 4 pi over 6. So I'm going to count 1, 2, 3, 4. So it looks like the other end is at pi over 2, comma, 3. And halfway in between there is going to be 1, 2, 3. Oh, I don't think I went. Yeah, I did. Is going to be half of 2 pi over 3. Half of 2 pi over 3 is 2 pi over 6, or 1, 2 of these tick marks. So that puts the low point at pi over 6, negative 1. Where are the intercepts? Halfway between a max and a min, there's one at the point 0, 2, and there's another one at 2 of these tick marks, 2 pi over 6, which is pi over 3, 2. So it looks kind of like that. So there's one cycle. And again, you could do this on Desmos or your graphing calculator and kind of simulate a viewing rectangle there. Your x min would be negative pi over 6, your x max pi over 2, and running from negative 1 to 5 on the y-axis if you wanted to do that. You could pick a point and check. For example, we could check the point pi over 6, negative 1, and plug it into the equation. Y is supposed to equal 2 plus 3 cosine 3 times pi over 6 plus pi over 6. Okay, that's 2 plus 3 cosine 3 times pi over 6 plus pi over 6 is pi over 3. That's 2 plus 3 times the cosine pi. That's 2 plus 3 times negative 1. And that does give us negative 1. So that's a good answer, right? So I was able to check that I had the correct point there. And you could check these others as well, and you'll see that you have the right thing there. Okay, or even you could check the 0.02 and see if that works in your equation. All right, so it's going to take some practice, and that's just what the homework is for, is to give you some practice on sketching these kinds of graphs. The ones with complicated, you know, lots of translations and so forth tend to be the ones that students have the most trouble with. But I think you've done this before, so hopefully it'll come back to you and it won't be as tedious as you think it might be. All right, take care, everyone.